Today we're going to be learning about parent functions. So in Algebra 1 we study 3 parent functions: linear, quadratic, exponential. So we'll do other functions in other math classes, but for this one just these 3. So a parent function is the simplest function in a family of functions. All of the others in the family are found by translating or adjusting the parent function. So we're going to start with linear. Linear's equation is y equals x. So what I'm going to do to get a table for this, I'm going to use the calculator. Y equals x. Then I'm going to go to the table, second graph, and I'm going to fill it in. So for -2, my y value is -2. For -1, I have -1, 0 is 0, 1 is 1, and 2 is 2. So then I create the ordered pairs for each one of these by filling in my x and y values as it says. From here, I'm going to graph it. So remember, x values go right and left, y values go up and down. So I'm going to go right or left first. So I have -2, so starting at 0, I go left 2. And then the y says -2, so I go down 2 and plot my first point. Then I have -1, -1, so -1, -1. 0, 0 is the origin. Then I have a +1, +1, +2, +2. From here, I want to connect the dots and create my line. So I can use a ruler or some other sharp edge. I'm just going to use a piece of paper. Also, if you have a school ID, they work really well because most of the time we don't carry rulers around with us. All right, so from here, I'm going to answer my question. So domain is going to be all the x values and range is going to be all the y values. So domain is going left and right. So if I look at this graph and I follow it to the left, notice it keeps going on forever and ever. And it's actually going the negative direction if you think about a number line. Negatives are this way, positives are this way. So I'm going to say it goes to -infinity. Then I see how far it goes in the right direction or the positive direction. Notice the arrow tells me it keeps going, so that's going to be +infinity. I'm going to leave some space, put my positive. Now we're dealing with domain, so I have to tell everybody reading this that it's x values. And then we think about which one of these is less or greater. We know negative numbers are always less than positive numbers, so I'm going to use less thans. And also we know we can't equal infinity. It's not an actual number, so you can't equal it. From here, now we do range. So we're going to do something similar to domain, but instead of going right and left, we're going to go up and down on the y-axis. So here, our negatives go down, our positives go up. So I'm going to see how far down it goes. So I'm following this arrow down, and notice it's got an arrow. So just like with the domain, I'm going on forever and ever in the negative direction. So -infinity. Then we go up and see how far up towards the positive it goes. Notice it's still going on forever and ever. So I would leave my space, +infinity. This time, instead of dealing x in the middle, guess what? We're going to do y. Negative is still less than positive, and we still can't equal infinity. Next, we have x-intercept, so we find our x-axis, and we see where our graph crosses this x-axis. Notice it's at the origin, so I'm going to use the point 0, 0. Then we have our y-intercept, so we look at the y-axis. Where does it cross that? It also crosses there at 0, 0. Now this word right here, asymptote, we'll explain what that is a little bit later, but for now, we're just going to say it's not applicable, so it does not apply to this graph. All right, let's go ahead and move on to the next one. Next, we have our quadratic function. So this one should be new. You may have seen linear before now. So we're going to go here and notice our function is y equals x squared. So I can clear that out. I'm going to go to x, and then if I hit this little button right here, power of 2. So notice it matches right there. Go back to the table. And now I can fill it in. So -2, it should be 4. -1 is 1. 0 is 0. 1 is 1. And 2 is 4. So once again, I create my ordered pairs. And I'm going to plot my points by going right and left first, then up and down. So left 2, up 1, 2, 3, 4. Okay, left 1, up 1. 0, 0, we're at the origin again. +1, +1, +2, +2, or sorry, 4. Notice it's not a perfect line like the one above it. Quadratic actually has what we know is this U shape, and it's actually called a parabola. So now we do domain and range. So domain, once again, we're looking at the x-axis, and we're seeing how far to the negative and how far to the positive it goes. So if you'll notice, kind of following this along, see how it gets further and further out each time? If I were to keep following this, it would keep going to the left forever and ever. So we're going to say that's -infinity. Then we follow this arm to the right, and notice it keeps going on forever and ever. So leave our gap, +infinity. Our x goes in the middle, negative is less than positive, and we can't equal infinities. From here now we have range. So let's see how far down towards the negatives it goes and then how far up towards the positives on the y-axis. So notice it doesn't go on forever and ever. It goes and then it goes back up. So look at how far down it goes. This right here on the y-axis is 0. So we say it goes down to 0. Now we look how far up. Notice there's arrows on both sides. It's going to go up forever and ever. So leave our gap and it does go to positive infinity. Our y goes in the middle. 0 is still less than any positive number. But notice, see how there's a point there? We're going to say it's equal to. Because we can equal 0, we just can't equal an infinity. X-intercept, so we find our x-axis where it crosses or touches, and that's going to be at 0, 0. Then we have our y-intercept where it crosses the y-axis. Once again, 0, 0. And this one, we also do not have this on this graph. All right, last one, our exponential function. So I'm going to go here, clear that out. And notice it's got letters. So instead of the letters, we're going to use numbers, y equals 2 to the power of x. This is going to give us our parent function. So I have 2, and then I can use the caret button as power of x. Now I go to my table. So for negative 2, oh, this one actually starts at negative 1, so I have 0.5. 0.5 you could also say is 1/2. 0 is 1, 1 is 2, 2 is 4, and 3 is 8. So create our ordered pairs. I'm going to actually put 1/2 right here. You can do either one. I'm just showing it different ways. 2, 4, 3, 8. So now we graph. So negative 1 and then 0.5 is only about halfway up. So I'm going to put it in the middle of those lines. 0, 1, 2, or 1, 2, 2, 4, and 3, 8. Now this is where this word comes in handy. It's called an asymptote. It's an imaginary line my graph can't touch or cross. In this case, ours is going to be the x-axis. So it's an imaginary line right here. My graph isn't allowed to touch or cross it, so I'm going to get really, 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 really close to it, and then I'm going to follow my dots up. And if you actually look right here, see how it gets smaller and smaller? Oh, sorry. It gets smaller and smaller, but it's never equaling 0. So that's how I know it never touches it. So now we do our domain and range. So x-axis, negative to positive. So notice it keeps going on forever in this negative direction. And as we go towards the right, it keeps going a little bit wider out each time. So once again, it's negative infinity to infinity, x in the middle, and negative is still less than positive. Next, we have our range. So remember, this gets really close to this line, but it doesn't touch it. So it's getting really close to that 0, but it doesn't touch it. So we're going to still use 0 as the bottom part of it. And it goes up forever. But remember, it can't touch this 0. So I'm not going to put an equal to here like I did on the quadratic, because quadratic actually had this dot right here. This one doesn't. X-intercept, it crossed our x-axis right here. That point is going to be 0, 1. You can actually see it right there. Y-intercept, remember, oh, sorry, I got that mixed up. X-intercept, so it doesn't cross our x-intercept, so we would say none. Y-intercept is where it crosses at 0, 1. And this time it does have an asymptote. It's our x-axis. The equation for the x-axis is actually y equals 0. All right, that's all the information of our parent function. The one things you really want to focus on for this unit is you want to focus on the name, the way it looks, and then this equation right here. All right.